Thank you for joining us. The room was looking pretty empty when we first came in here, but I'm pretty happy that it's filled up. So thank you for being here. Quick note, if you're scared to drink the coffee after last time, if you did have it, it tasted like chemicals. That was because there was soap residue in there. It has been very thoroughly cleaned. Do not be scared. Coffee tastes great today. So go ahead and have that if you do want it. Before that, it was plugged into the wrong outlet, so we've had 2 weeks of not great coffee situation, but we're back on track, so it's there. Today, it is my pleasure to introduce our speaker, Catherine Batista. She is currently a research technician here at the University of Calgary, working collaboratively between the lab and the One Up Research Group. She completed both her Bachelor of Science and Master of Science degrees in exercise, sport, and movement science at the University of Memphis under the supervision of Dr. Max Paquette. During her undergraduate program, Catherine conducted a senior research thesis examining biomechanical predictors of running economy and metabolic power in well-trained male runners. She then went on to complete her master's thesis, which was focused on investigating the effects of the steep forefoot curvature in advanced footwear technology on the biomechanics and metabolic costs of female runners, which is what she will be talking about in today's talk. Before we jump into that though, a couple of quick fun facts about Kat. She is Brazilian, was born in the US, lived in Australia for a little bit, grew up in China, and now she's in Canada. So that's a pretty diverse background. And then in her free time, she does like to run, and I added this one myself. Kat started liking matcha before matcha was ever popular, so that's a pretty fun fact, I think, as well. Thanks, Kat, for doing this, and of course, all yours.
Okay, thank you, Ashley. So I want to start off today with a little bit of running history. So if you didn't know, running didn't take off as a recreational sport until about the late 60s and really gained its popularity in the early 70s. But at this time, it was mostly a male-dominated sport, and in fact, many women weren't even allowed to participate. You might have seen this picture from Catherine Switzer in Boston Marathon, 1967, almost getting pushed off of the race course because, again, women weren't allowed to participate. In fact, it wasn't until the 1984 Summer Olympics that the women's marathon became an official Olympic event. Luckily, though, since then, the participation of women's running has increased and continues to do so. And today, women actually make up over 50% of all road runners. So with this increase in running participation, we've also seen trends in world record times since the 1980s. So if you take a look at this graph here on the right, we have race times as a percentage on the y-axis, and each one of these lines represents a different race distance. If you look at the trend of these lines, it's such that each line over time kind of decreases, and that's the event times decreasing, so people are running these race times faster. I've also highlighted it on the left some of the more popular road race distances, just to quantify the magnitude of improvement we see as a percentage in across these events, which is anywhere between 8 and 15%. So there's a lot that goes into these improved world record times since the 80s. Obviously, we know so much more about human performance and such today than we did back then. But one piece of this puzzle that I want to focus on today is footwear innovation. So if we take a look at footwear innovation from the 70s to today, we see some drastic changes right off the bat. I've highlighted here a 1977 runner's catalog that shows what the training shoes back in the day looked like. So in the 70s, it was all about minimal cushioning, whereas today we see thicker midsoles that lead to higher stack heights and larger geometries overall. Whereas in the 70s, we had a more minimal profile. The upper construction of the shoe is also very different. In the 70s, it was more common to see nylon upper constructions or leather type materials, whereas today we opt for a more lightweight mesh upper. And then a big change that we see from companies is the differentiation of the daily trainer and a performance shoe. So today, most companies separate their shoe designs into your everyday running, jogging, training shoe, and then a shoe that is designed with the intention of improving performance. Whereas in the seventies, the shoe that you trained in was likely the same shoe that you raced in. And in fact, the shoes from the seventies more closely resemble our lifestyle shoes of today than they do our modern running shoes. Just so you can get a picture of how much these shoes have changed over time. And today's shoes, they're designed with a specific goal-driven outcome. So each one of these shoes targets a specific outcome, such as reducing fatigue or improving race time. Some shoes are even designed by distance. You can buy a 5K shoe or a marathon shoe, and they might have different characteristics. And these modern shoes of today that are designed with a specific intention of improving performance are called advanced footwear technology, or AFT for short. And a lot of these AFTs have a few common features, and these features are designed, again, with the intention of improving performance. Some of these characteristics are the lightness of the shoe, so it has a lightweight profile, the high stack height, typically seen at the rear foot of the shoe. It has a compliant and resilient midsole foam, typically made from PIBA, although today we see all sorts of blends. It has an embedded stiffening agent in the midsole. Usually this is a carbon fiber plate, although today we also see carbon fiber rods or nylon plates. And lastly, a rocker-shaped geometry at the forefoot. So all of these characteristics are common in these AFTs and have been studied thoroughly in the literature and have shown to improve running economy, which is our measure of performance, in many different ways. So if we take a closer look, the lightweight profile of the shoe improves running economy because of the relationship of mass and metabolic cost. So we know that for every 100 grams of added shoe mass, there's about a 1% increase in metabolic cost. So if you can take the shoe and make it lighter, you can likely improve running economy by decreasing the metabolic costs associated with that shoe. Then we have the compliant and resilient midsole foam. It's also really light, but it contributes to a greater energy return because it's both compliant, which means it can compress, but it's resilient, which means that it can go back to its original shape quickly. And this is more efficient. And then we have the embedded stiffening agent, which reduces shortening velocities of the plantar flexors, allowing for more efficient propulsion that decreases metabolic cost. Lastly, we have the forefoot curvature, which is under-investigated, but at the same time has been mentioned in a few of these papers and is associated also with more efficient propulsion. So all of these characteristics have been studied, and the consensus in the literature is that it improves performance from anywhere to 2 to 6%. And these were the questions of 2016 when the first AFT came out, and we, as researchers, we were looking at which characteristics were contributing to this. Now the questions have changed a little bit, and we're looking more at what makes somebody a responder to these improvements. What makes someone respond 2% versus 6% versus 4%. And that's kind of what I wanted to look at. So some of these differences could be sex differences. Males and females respond in the same way. Training levels, do recreational runners respond the same as elite runners, or even gait kinematics or gait characteristics such as foot strike pattern. So if we take a look at one of these groups, sex differences, we can ask, do female runners respond to AFTs the same as male runners? This was a question that a previous lab mate of mine back in Memphis sought to answer, and he found that females improved about 3.2% compared to the average male, which is about 4%. Does this mean that males and females respond differently to AFTs? We don't know, right? We don't know enough about this to make any sort of claims, but at the time when I was setting up this study, I was very curious about what could lead to these differences seen between sex. And diving into the literature, I found this paper, and they found sex differences at different regions of the foot during running kinematics, they found differences in running kinematics in different regions of the foot. And they found that women actually exhibit more dorsiflexion excursion at the MTP than males. And this is an important relationship because of the relationship between negative joint work and at the propulsive and braking phases of running. So what this looks like is there's dorsiflexion at the joint, which increases negative joint work. And this leads to more metabolic costs. So it reduces running economy. And this relationship is seen both at the ankle and at the MTP. So if you can take a shoe and manipulate its characteristics in such a way where you can reduce negative work at either or both of these joints, then you can reduce metabolic costs and decrease running economy and improve running economy by reducing metabolic costs. This can be achieved through the forefoot rocker by decreasing negative work through decreasing positive MTP power, decreasing negative MTP power, decreasing plantar flexion torque, and decreasing dorsiflexion excursion. My question was, these all improve running economy. My question was, if this is true of a traditional forefoot rocker, would a steeper rocker have even greater reductions in metabolic costs? Would it improve running economy more? So the purpose of this study was to investigate the effects of a steep forefoot curvature on running economy and MTP and ankle joint mechanics of female runners. We hypothesized that running economy would improve in the traditional AFT compared to the control shoe, and improve even more so in the rocker shoe compared to the traditional AFT as a result of reductions made in negative joint work. So we hypothesized that negative joint work would be reduced in the AFT compared to the control and further reduced in the rocker compared to the control. In terms of methods, we had 12 female participants. These had to be well-trained female distance runners. They had to meet a certain criteria to be able to run the speed of 3.38 meters per second. They had to run at least 4 times a week, and they must have had to complete race distances of a half marathon in under an hour and 44 minutes, a 10K in under 47 minutes, or a 5K in under 22 minutes to assure that they could reach and run this speed sub-maximally for the duration of the test. For data collection, we use a 12-camera 3D motion capture system to collect kinematics. We use a force instrumented treadmill to collect ground reaction force data, and we use a metabolic system to collect expired gases. For our shoes, we chose the Nike Pegasus 38 as our control shoe, the Nike Vaporfly as our traditional style AFT, and the Puma Fast Forward Nitro Elite as our steep rocker condition. And this was just our standard marker set. We had a pretty standard testing protocol, so the participants would come in, warm up in their own shoes for 5 minutes, and then run in each condition for 5 minutes, 6 times at a 4:40 minute per kilometer pace, and had 8 minutes of rest in between each shoe condition. This testing order was randomized and then mirrored. So what this looks like is participant would come in and run in the first shoe for 5 minutes. After 5 minutes, they were given an 8-minute rest period. During this rest period, we removed the markers and redid the marker static calibration, and then they would run in the second shoe for 5 minutes. This process was repeated again for the third shoe, and during this time is when we collected motion capture and metabolic data. Then this was mirrored so that they ran in the third shoe again for 5 minutes, and then had 5 minutes of rest, ran in the second shoe again, had 5 minutes of rest, ran in the last shoe, had 5 minutes of rest, and during this time, we collected metabolic data. In terms of data analysis, we use Visual 3D for analyzing kinematic and ground reaction force data for our main dependent variables. In terms of running economy, we chose VO2 and metabolic power. We averaged the final 2 minutes of each trial in each shoe condition for this. And for statistics, we use a paired sample t-test to assess differences and Cohen's d effect sizes to assess magnitudes. Okay, our results. So the effect of forefoot curvature on running economy. Contrary to our hypothesis, the rocker condition did not further improve running economy compared to the AFT. Although we did see some improvement of 1.8% between the rocker and the control, it was non-significant. So the only significant difference we saw was between the AFT and the control. This was seen in both metabolic power and in VO2, both of our running economy measures. So what we found was the shoe that improved running economy the most was the Vaporfly Next Percent 2. And if you think back to our earlier slide of why we hypothesized this was the case, was negative joint work occurring at, or negative work occurring at the MTP and ankle joints. So if we take a closer look at the negative work at these joints, it helps explain our findings. Here I have 3 graphs showing angular power. These are the exact same graphs, that just that I've shaded the area under the curve differently to correspond with each one of these shoes. So as you can see, the control shoe had the greatest amount of negative work at the MTP joint, and then it was decreased in both the AFT and the rocker. But the decrease in the AFT was greater than the decrease seen in the rocker. And this likely contributed to our running economy results. If we take a closer look at MTP joint mechanics to understand why we saw more negative work at the MTP joint in the rocker than in the AFT, we can understand why this was the case. So we take a look at MTP velocity. We saw greater angular velocity in the control shoe and then decreased amounts in both the AFT and the rocker, but the AFT still had the least amount of velocity, and this explains our results seen in negative work at the MTP, because the greater the velocity, the more power you have, and because we take work as the integral area under the power curve, it makes sense that the increased velocity led to more negative work at the MTP joint. We did, however, see decreased sagittal MTP torque in the rocker conditioning, but this wasn't enough to contribute to more savings in running economy. Taking an even closer look at these mechanics, we have MTP dorsiflexion excursion, which was reduced the most in the traditional AFT compared to the control, even though we did see reductions in the rocker compared to both the control and the AFT, the traditional AFT reduced it the most. And again, for peak MTP plantar flexion torque, we did see a decrease in the rocker compared to both the AFT and the control, but this was not big enough to see large differences in our running economy results. So these are the findings we had for the MTP joint, but actually at the ankle joint, we saw something a little bit different. So again, I have the 3 graphs of angular power with the area under the curve representing negative work. And each one of these shaded areas corresponds to these shoes. So the control had the greatest amount of negative work at the ankle and was decreased in both the AFT and the rocker, with the rocker actually having the least amount of negative work at the ankle. Taking a closer look at these mechanics to explain this, we see ankle velocity was also reduced the most in the rocker, and sagittal ankle torque was reduced the most in the rocker. So it makes sense that we saw greater reductions at the ankle due to these variables than we did at the MTP. Similarly, we saw reductions in ankle dorsiflexion excursion in the rocker compared to the control, but not compared to the AFT. And then we saw decreases in peak ankle plantar flexion in the rocker compared to both control and AFT. But the differences seen and the reduction seen in the ankle wasn't enough to further improve running economy like we hypothesized. So some reductions were made, but likely the MTP had a greater influence to running economy than the ankle joint. So a summary of our findings was that the rocker improved running economy more than the control, but the AFT improved running economy the most. As a refresher, we hypothesized that running economy would improve by decreasing metabolic costs, decreasing MTP dorsiflexion, decreasing MTP negative work, decreasing ankle dorsiflexion, and decreasing ankle negative work. But actually we found the opposite in some of these. So running economy costs, metabolic costs were increased, MTP dorsiflexion was increased, MTP negative work was increased. And we did see decreases in ankle dorsiflexion and ankle negative work as hypothesized, but again, these weren't substantial enough to make larger improvements in the rocker compared to the AFT in terms of running economy. This study has some limitations worth noting. For one, we had a small sample size, so we were actually underpowered, and we had different shoe properties since these shoes were from two different companies. Both the foam blend would be different and the stiffness of the plate, as well as the stiffness of the foam overall. We only tested on well-trained female runners, and we only tested at one testing speed. Although, moving on. In conclusion, we found that a steeper forefoot curvature did not further improve running economy in female runners compared to the traditional AFT, and the forefoot curvature alone may not enhance performance the way we thought. In the future, we'd like to continue investigations and look at the interaction of stiffness and curvature to minimize MTP energy loss, and also to investigate these responses in males to see if we find similar findings. And thank you so much.
With that, the floor is open for questions. Who would like to start us off? Venus.
Nice presentation.
Thank you.
I have a question about the resolution of your metabolic costs measurement. Because you're reporting values of 1.5%, 3%, the difference between males and females, 3.2 and 4%. So how much is the resolution of your measurement? If you repeat the measurement, same person the next day, how much the variation is going to?
We didn't do, we didn't retest on different days, so I'm not sure exactly what that would be. But what I can say is this result was seen in that first study from Martinez et al. In the same lab, and he found about 3.2%, and then his study was replicated, and again, another student in our lab also found similar results of about 3.2%, and mine was about 3.3%. So these findings were pretty consistent. It was all within our same lab, but I'm not sure what that would look like across different labs.
So what percent difference would you expect to see just from a change in sole material and carbon fiber plate thing on their own? You have the exact same shoe, but the foam was different, and the whole everything else was kept constant. If you just changed one of those variables, what type of difference would you expect to see?
I think it's hard to say for sure what the difference would be. Probably about 1% is what you see in the literature, at least from adding a plate versus not having a plate, or the lightness of the foam. But it's hard to say exactly because I think it's more so of an interaction effect between the types of materials than one single material.
So then do you think, since you had your steep slope, one was completely different than your AFT, so do you think it would just literally be a wash due to the fact that two other components of the shoe were completely different? And it wasn't just one variable that changed?
Yeah, I think it's a limitation of the study, because we weren't able to prototype the shoes and just isolate the effect of the curvature. So it's hard to say, but maybe if we could repeat this study with similar shoes, we could get a better understanding of that.
Matt and then Cole.
Was there So you used an all-female population. Was there anything in your hypothesis of why the increased curvature of the rocker might be of assistance to like, female population, or was that was there's going to be common?
So the reason for that was because of that paper from Takabayashi et al. That they saw a decrease in, or sorry, women had a greater amount of dorsiflexion occurring at the M2P joint, which would lead to more negative work at the M2P, and that's usually more costly because it's energy loss rather than energy absorption. So that's why we looked at the rockers specifically, because we thought that that could potentially limit this dorsiflexion.
Colin, you're on.
Great work, Kat. I was just wondering, maybe I missed it. Were you able to like characterize the properties of the shoes? Like, did you take masses or do any stiffness measurements or anything like that?
Thank you for asking. So a little bit, yes. So we have the masses of the shoes here. And we quantified the 4-foot slope just to make sure that there was a difference in that 4-foot slope. I put rear foot slope in there too, just to get a better understanding. These stiffness values, however, were not from our lab. They were from this paper here. I can't pronounce that name, but their lab did the same, did these stiffness study, these stiffness measures in the same shoes, the Vaporfly X% and the Fast Forward Loop.
What about like the location where that rocker, like the 4-foot rocker starts? Do you measure that from like the toe or something, or characterize that?
I did actually, but I don't have it on this slide.
Is it further back on the Google one than it was on the Nike? It's hard to detect.
I can't remember off the bat, but I can.
The other thing I'm curious about too, I'm just trying to like what Andrew's getting at, like compare, what could be driving that lack of a difference you're seeing there. And I'm wondering if, obviously they're using different foam formulation, I assume.
Mhm.
So if you had a measure of energy return or something like that of a foam, like more dynamic measure rather than just the mass, it might be something to potentially point actually.
Yeah, that would have been really interesting to see. I know both foams have like are a Piva blend for sure, but I don't know the specific like metrics of that.
I have one more question too. Well, yeah. When I was looking at your MTP joint curves, you had them going from 0 to 100.
Mhm.
What was that scale? Because usually when I've seen in the past, it's from stance 0 to 100% of stance. Usually they'll start kind of towards the latter half of stance once the center pressure moves in front of the MTP joint. So how did you guys?
Right, so this wasn't the entire stance phase, it was just from I think initial contact to when the MTP was off of the final, the 100% is where the MTP is off of the, like, not the entire, not the end of the stance phase.
So
Sorry,
you clipped it a little bit then?
yes, exactly.
I have a quick question. Did you compare your positive ankle joint work in the shoes as well, or just the negative?
We did not, I think we have that data, but I was more focused on the negative joint work.
The reason I'm asking is because if you go to one of your ankle joint power curves, like the same slide
Yeah.
where you have the ankle joint.
Yeah.
To me, it looks like the rocker lies right between the control and then the AFT. And I'm wondering if the positive work is what is driving more of your metabolic result explanation, because the rocker has to do more positive ankle joint work to propel the runner. And maybe that's what's like making their running economy come somewhere between the two. So I don't know.
Yeah,
Any
that's a very
suggestions?
good point. Yeah, definitely have that data, so I could definitely look into that. I just didn't include it, for this, but yeah,
Right.
thanks.
And that kind of goes into my next, not really a question, but more of kind of like a comment.
Mhm.
I'm wondering if like having I guess you did talk about the fact that you're measuring the effects of a steeper curvature or a steeper toe curve. And to me, it looks like that curve going so abruptly, like being so straight versus like curved in the Vaporfly might be what maybe causing that increased ankle joint work that then results to your metabolic cost results not being the best for that one.
Yeah, I think that definitely could have played a role, especially in increasing the velocity in that shoe, because we did have kind of like the increased velocity, and I think that's part of it. I think even if the rocker was as steep as it was, but there was more foam under that forefoot region, maybe we would have seen different results. Right. But that's just a limitation that we couldn't control for. Yeah.
Other questions for Kat? Walter?
Yeah. You mentioned that I can go and buy shoes today, and if I buy a 5 kilometer shoe compared to a marathon shoe, it will be different. Can you explain to me what the difference might be between those two shoes?
Yeah, so from what I know, which could be different, but a 5K shoe probably has a little bit less foam, and then a marathon shoe would probably have a lot more foam, just because of the duration of the race is so much longer.
So more foam, meaning like more cushioning, or
Yeah, more cushioning,
a little heavier maybe?
depending on the shoe maybe, and depending on the foam, but they might also be similar in that state.
The same for like a competitive shoe and a training shoe?
I would expect a competitive shoe to have different characteristics, so maybe different foams, and maybe the training shoe would be a little bit heavier.
So, I'm thinking about why wouldn't I run in my competitive shoe if that's the fastest shoe all the time? And so I guess the explanation might be that I might get injured more frequently, that it might be a faster shoe, but it might not be so nice to me in terms of preventing injuries. Is that kind of the thinking, that you have a shoe that protects you more from injuries?
I think it's a good question. I think that is a question that people in the AFT world are kind of looking at now, if, these advanced shoes are related to some sort of injuries, but I don't think that's the reason people don't wear them regularly or on a daily run. I think it's more so to do with, one, it's more expensive to make and buy. The foam wears down a lot quicker than a regular training shoe, and so it makes sense to kind of separate the two shoes into different categories, and you can use one more frequently than the other. And then also, you do see people training in these fast shoes, maybe once or twice a week, or when they're doing their more quality workouts. But it also takes more work for the runner to have kind of like push themselves in those shoes, which would be similar to a race. And at slower speeds, it might be slower, easier speeds, it might be more difficult to do that in an AFT than in a daily trainer, if that makes sense.
Yeah, the other thing I was wondering, you measure oxygen uptake, and you find there's different shoes you have that need a little bit more, a little bit less. And then you also have these power over time curves, which essentially, if you integrate them, gives you a work term. And the work term in muscles is usually associated with energy cost. Have people ever tried to relate the energy cost, let's say at the ankle or the NTP joint, to the difference that they see, that they can say, oh, I need 2% less oxygen, and that can be exactly explained by the reduction in negative work that I have here.
I'm not sure I understand the question, sorry.
Muscles require the energy.
Yes.
And muscles are, what drive the joints through their movement in a certain way. And, you show this power as a function of time curves for the different joints. And I know if I need more power over time, if I perform more work at a joint, I need more muscular energetic work. I need more ATP to make that happen. More work in the muscle means more ATP, which means I need to have more oxygen.
Yes.
And I was wondering if anybody ever tried to look at these differences in the work at different joints and try to convert that into oxygen uptake and then say, oh, I can explain it exactly, you know?
Yeah, that's a good question. I'm not sure exactly if that has been seen before. I do know that this is why we take measurements of metabolic power or similar to what you're saying, because collecting VO2 tells you the volume of oxygen that the runner is taking, but it's not explaining the energy expenditure, and metabolic power is a way we can look at energy expenditure specifically, and it is it does take into consideration like muscular work. But I'm not sure if you could relate specifically the two and see a 2% difference in volume of oxygen uptake equals a 2% difference in like mechanical work at the joint.
Which I guess, you know, goes to the other point. You look at the ankle and the knee joint, but I assume the other joints might be affected as well.
Yes,
The
yeah,
other running joints, you know, the knee and the hip and so on.
yeah, for sure they could be, and I'm sure that they do contribute some amount, but for the study, we just wanted to focus on the ankle and knee joints.
Walter, to kind of touch on your point as well, some of the work that I looked at in the PhD and then some of the other work from our lab. The one interesting thing that we've seen is that the hip joint work substantially decreases in an AFT versus the other shoes, traditional shoes. So it's kind of like a redistribution where more work was coming from the ankle and the MTP and less work was coming from the hip. So we kind of suggested that the bigger muscle groups have to do less work in these EFTs.
Which then might explain the difference. Yeah.
Right.
And the last question that I have, you know, I find it interesting that you said that when people run in these shoes, you know, they go from one shoe to the next one, then they might be based on oxygen uptake, 2% more efficient or up to 6% more efficient. And then you said people trying to find out, you know, what is it about a runner that might be 6% more efficient compared to 2%? Do you have any, well, has anybody done that systematically, or do you have any speculation what might make somebody much more efficient with a Nike Vaporfly?
Yeah, I really don't know. It's something I would really like to find out what makes somebody a responder, what makes somebody respond 2 versus 6%. But I think it's an interaction, I think, of a lot of these metrics, both biomechanically, physiologically, but also psychologically, and how what they believe about the shoe. And I think all of those play a role. I don't think it's as simple as we would like it to think. Yeah, like thinking, oh, with this variable makes it more efficient, more or less efficient. But I would love to find
There's
out.
not really, nobody has really an accepted solution. You know, if you're heavier, you profit more. If you're a 4-foot striker, you profit more.
Yeah, exactly. There's been a lot of papers kind of trying to differentiate these groups and seeing which groups kind of maybe respond more or less so. But there hasn't been a consensus between different studies saying that that somebody might respond more or less.
Because you cited that, I guess, interesting study, if I understood it correctly, you know, where they compared the men and the women, and they reacted different. I'm not really sure that women had a greater increase in efficiency or
So they would have less efficiency.
less.
Yes.
So the men had a greater decrease in oxygen consumption when they are in red flag. And then you said that was associated with strike patterns, foot strike patterns. Is that correct?
It wasn't associated with foot strike patterns specifically.
Okay.
That was just what I hypothesized, that if we could decrease the dorsiflexion, that when they exhibit, it could lead to an increase for reductions in metabolic costs, improvements in running fundamentals.
So people have looked at foot strike patterns in men and women and found distinct like systematic differences, or
I don't know about, foot strike patterns in men and women specifically, but the paper that I did cite, from our lab did look at, foot strike patterns in the female runners that he collected, and he didn't find any differences there between mid forefoot and their foot strike.
In terms of efficiency when they went to the vapor flight.
Yes.
So it didn't really matter if you're a heat striker or a fortress
Yeah.
striker.
No, it didn't. And from my understanding of the literature, that seems to be the case. But I can't remember specifically if there was one looking at males and females in that.
That's interesting because then that essentially would mean that how the heel is shaped or what the material of the heel is doesn't really matter because forefoot striker will not really lose the heel. But it seems to get the same benefits than the rear foot striker.
Yeah, could be. I think so.
Sandro had a question and then Ben.
Can you put up the metabolic results?
Yes.
So I want to talk about responders. Like when I think of the Whocomer paper, every single subject in that paper had the exact same result, like metabolically. And when I look at your results, the majority kind of have this be your average. So if you have responders in your data set, you might have two, what did you have, 12 subjects? And in Whocomer, we have 0 out of, or they're all responders, they're all not responders. So looking at these two studies, do we have responders? Or is just everybody reacting the same to these kind of tests?
So I think in these results, I would say majority of these were responders, the ones that follow this kind of shape curve. Those were the people that did improve. They improved the most in the AFT compared to the other two shoes. The two kind of outliers, or maybe 4 outliers, depending on how you can look at it, would be that bottommost line and the topmost line. Those I would consider non-responders because they improved in one shoe or not the other, or didn't improve at all. This last one here is most efficient in the control shoe, which is not what we would expect to see. And in the rest of them, they kind of responded similarly. But I didn't have any, looking at their data specifically, I didn't see any mechanical differences that would lead to these results, which is what makes me think that what makes somebody a responder is more than just their biomechanics or their physiology or their training history or their favorite shoe brand. I think it's a combination of all of these things that lead to these kinds of results.
Yeah, like if you look at your average, the difference is about, what is that, 1%, 1.5%? And the error is what, 1%? So maybe I'm using the term responder wrong. I think a responder in this data set is that one that's at the very top and goes way down in the rocker. That is a response to a difference in footwear property. Right? That Puma shoe has some different. Does it have a plate, by the way?
It does,
It
yeah.
does have a plate. So is this the precursor of the Pastor 3?
No, it's a different line, yeah.
But getting back to, I would love to see the data for that one subject that you're looking at, right?
Yeah.
Because there you have an effect. You have a difference of 12% in running economy. So if you want to answer the question whether your other variables are affected by running economy, I'd look for people where there's big differences between shoe conditions.
Yeah, so I did look at that subject specifically, and to try to figure out what mechanically was contributing to this result because they had such a big response to the shoes. But there was no differences in their mechanics compared to somebody else, compared to any of these other subjects. So that's what kind of leads me to believe that there's something else playing a role. That subject in particular is a friend of mine, and I know she's a really big fan of Puma shoes, which is, it's a funny thing to say in a science environment because we like to believe it's a certain variable. But again, looking at the mechanics, I couldn't see any differences. So it's it's hard to say.
And I think there was just a study done. Is it Lozier, where they gave them the exact same shoe, but said one was an AFT and one was not an AFT to see the effect of what you think.
Exactly.
And you would know that, but there was no difference, right?
They rated it as like more comfortable, or they rated the fact that the one called VHT was making them faster, but the running economy results were the exact.
So running was all the
Yeah.
same. Yeah,
Yeah, I think, perception data along with this would probably go a long way. But yeah, I'm not sure.
can I have one more, just a technical question? You have a dorsiflexion excursion, range of motion. What's the difference between dorsiflexion excursion range of motion and dorsiflexion range of motion?
I think, if I'm correct, I think dorsiflexion excursion is from like the beginning to the end of the movement, so it's their entire range. Whereas range of motion is just their, it's not the entire movement phase, it's just how the maximum range of, that they're able to. I think,
So excursion is based on time and range of motion is based on the entire range over all time.
I think so, from my understanding.
Walter, did you have a comment on
I
that?
just wanted to come back to the O'Connor paper. I mean, he has written many papers, but the 4% paper is rather common that I'm aware of. I mean, the difference might be they were males, they were highly elite runners, and they were running at a much faster speed than in the US study. And, you know, all those factors might potentially make a difference. And just a little comment to your friend who likes Puma. Puma sponsored me for many years, so I love Puma too. Nothing, no commercial, you know. I'm actually wearing Nike shoes right now, so. They sponsored me when I didn't have any money, which was very nice.
Daniel, you had a question?
Yeah, if you look at the Puma shoe, would you have designed that forefoot like that?
I think if I had designed the shoe, I would put a little bit more foam underneath the forefoot, but I would keep that aggressive rocker.
Kind of awkward, isn't it?
A little bit, yes.
So you
Which is why I also think that perception data would have been, really interesting to have in hindsight. Maybe some of the runners put on the shoes and decided this is such a weird shoe, I don't like running in this.
And the interesting thing is, you know, that you have a lot of studies that address the question, which is the right shoe for that thing. And you cannot say anything, and we cannot say anything, and nobody can say anything. Why is that the case?
I think shoes are highly individual. So it really does come down to what the runner prefers and what they think is the best shoe for them, and it might affect their results.
I don't think that there are some basic rules that have to be followed. That the condition A, this has to be fulfilled. Under condition B, this has to be fulfilled. I don't think that's something like that.
I'm sure there is, but I think at this stage of AFT research, we're not definitive on what those are exactly, but maybe we'll have there eventually.
I guess it's because we know we do the wrong study, so why is it?
Yeah, could be,
You know, it looks to me like we have forgotten certain important factors that play a role, and we don't look at them and talk over here and don't have a chance to answer the question.
yeah.
If you could add one more variable, which one would you add?
That's a good question. Mechanical variable or
I don't know.
maybe the positive work, like actually.
Maybe they have nothing to do with mechanics.
Yeah, maybe not. If it doesn't have to do with mechanics, then yeah, like I mentioned, maybe perception, comfort, overall rating of the shoe kind of questions would be useful.
Did you take any anthropometric measurements from the participants?
Yes, I did.
Like, did you have, their foot measurements, for example, like the location of their MTP joint or
Oh,
something?
no, I did not.
The reason I'm asking is in one of my pilot studies, I'd seen some sort of relationship come up, but we didn't test it far enough to see whether the MTP joint lining up with the part where the curvature starts may have something to do with the work that they're doing. But if you don't have that, then.
Yeah, I think that definitely probably plays a role, but I didn't look into that.
I think we had an online.
I got an online question for you. The question is, can you explain why or how that one person had a lowest VO2 from 48 to 38 millio per kilogram per minute? And the rockers, is this a reasonable running economy at that running speed?
I don't know in terms of if it's a reasonable running economy, I'm not sure I understand that part of the question. But again, I did look at these outliers to see if mechanically there was something about them that was contributing to these results. And I couldn't find any differences. Looking at the participants that participated in the study, that specific subject had never run in AMTs before. And so I expect that was maybe that played a role into why they were most efficient in the control.
Okay, Jake, go ahead.
I was just curious, would you suspect if you could isolate for the geometry of the rocker, could there potentially be like some threshold of detrimental returns? Like, could this rocker be like too steep and then like it could improve up to a point and then it drops off, or maybe it has something to do with like the smoothness of the curve? Like that.
I think so. I think that's true of any of these shoe characteristics. We see that relationship in stiffness, right? If you have too much stiffness, then there's that U-shaped relationship. If you have too much foam, then the shoe becomes unstable. So even though I don't know the answer, I would suspect that, yeah, if you have too much of a curvature, it probably also has a U-shaped relationship where there's kind of an optimal shape that is the most efficient.
If you were to like design a future study, like how far would you go? Yeah.
In terms of slope,
Yeah, sure.
maybe something similar to the rocker. So here, the slope of this one was, forefoot slope was 83%. So maybe 85, just because I do think that you could look at that kind of higher end range as opposed to the more traditional range like the Baker's done.
Can I jump in? How do you measure that? What's 83.4%? I would have mapped, I don't understand.
Yeah, so these measures are from this paper, Gardner et al. They do this in walking, they do this in walking shoes. They do these in, walking shoes, but I took the methods from this paper to calculate, these measures for,
And you get a percentage.
yes. Yeah.
So 90% would be a 45-degree angle. 45-degree angle to the flat, or
I think. Yeah, I think so. I have to look back.
you know, when I asked the question, you know, would you design that shoe as well? You know, like this that thing. And I'm not sure if I would design it that way, but I would never buy it. I would look at it and never buy it.
Yeah.
Because I would look at it and I would say, how do I push off? You know, I'm losing my whole forefoot and my toes to push off with that shoe because there's all of a sudden there is a. So I was wondering, has anybody measured pressure distribution or when you measured them, did they actually roll onto that forefoot part or did they push off with the metatarsophalangeal joint? Especially at the slow speed, you know, where they don't really extend your joints anyway.
I actually haven't looked at the pressure data. We didn't collect pressure data, so I'm not sure what that would look like. But to your previous point about the curvature, I would expect something like this, right? So this looks similar to what the shoe we had. They have a bit more foam kind of in the forefoot, and this is the faster grade that Sandra mentioned, and maybe something like that might give you a smoother, like motion field.
And that's the shoe that's better than the Vaporfly.
Yes, we're showing right now.
That blue one,
3%,
3%.
3%.
Yeah.
I thought the Vaporfly was 4.
Oh, and now this is 3% better than the
Oh,
Vaporfly.
it's 3% better than the Vaporfly, so it's like 7%
Yeah.
compared to the old shoe.
Yeah.
Wow. Incredible how fast it is.
All right, any last questions for Kat here? If not, let's thank her for her talk.